Video will serve as a review of slope. So the rate of change on a linear graph, the rate of change is called the slope of the line. Slope is written as a ratio, and it's a ratio of the vertical change, the change in y, and I'll use the little triangle, which means change. The Greek letter delta means change. The change in y is the ratio of the vertical change, or the change in y, to the horizontal change, which is the change in x. And it's the ratio, the constant rate of change between any 2 points on a line. And this remains the same for any 2 points on the same line. Slope is written as a fraction or a ratio, and it's always usually written in fraction form. So slope is written as a ratio in fraction form, and the variable m is the universal variable to represent slope. Types of slope: we have positive slope, negative slope, zero slope, and no slope. Let's draw little grids in each, a little xy plane rather. Okay, get your notes set up. As you travel from left to right, if the slope is positive, the line rises as you travel from left to right. Moving from left to right, if it's negative, the line's falling. Zero slope is the flat line, and no slope, undefined slope, is your vertical line. And we will explore the horizontal vertical lines later in more detail. Okay, let's move on. So determining slope from a graph. Just count between pairs of points and change in y over change in x. This is not the formula for slope, just ways to describe the slope. Rise over run. Consider these descriptive terms for slope. And I guess either one of these could fit nicely into the box right here. Change in y over change in x, or rise over run. So here I've got a point here and a point here. If I count between the points, my vertical change would be up 7. My horizontal change is over 4. And notice traveling up is positive, and to the right, positive motion both ways. If you choose to start at the top, you're traveling in the negative direction, and then down is considered negative, so it's double negative direction, still forcing that slope to be positive. Looking at the graph in number 2, you can see I've got a point here and a point here. If I count between the points, the slope here, if I count between the 2 points that are pre-plotted, I would move up 3 and then over 9. So here I'm moving up 3 and over 9. So this is my positive motion, but moving to the left is negative movement, so that makes the slope negative. Or going in the reverse, if I started counting here, I'm moving in the positive direction, but then downward motion is considered negative motion. So I end up with a slope of negative 3 over 9, which I can then simplify down to negative 1/3. So that would be the slope for graph number 2. Graph number 3 is my flat line, or my zero slope, my horizontal line. So this is my zero slope. And then graph number 4 represents the vertical. So this is no slope or undefined slope. And as I said earlier, we will look at this in more detail later. But just for recognition purposes, just to get us started. Now let's move to calculating using the formula for slope. Here's your slope formula between a pair of points. And I've got x sub 1. So the way that I would say that, it's x sub 1 for subscript. So I've got the pair of points, x sub 1, y sub 1, x sub 2, y sub 2. The subscript just simply serves to tell you which pair of points, which x and y go together. So here's the classic standard formula for slope. The change in y first over the change in x. And just note that the first y coordinate that you start with in the numerator, you must start with that x partner in the denominator. So you can actually do the slope formula in the other order. You could start with the other point first. It's up to you. It works out both ways. You could start with y sub 1, subtract y sub 2, but then in the denominator you would need to start with x sub 1, just making sure that the x and the y partners from the same ordered pair are in the same spot when you're calculating the slope. Okay, let's run through the formula, calculate a few slopes. And first up, let's do number 3. Let's do number 3. All right. So here the letter M standing for slope. I'll let this be y sub 2, x sub 2, y sub 1, x sub 1. So I'm going to start with negative 5 minus 5. And then my denominator, negative 8 minus negative 4. So be careful with your signs. And then cleaning up the numerator, I have negative 10. And that's going to end up as negative 4. Negative 8 plus 4 is negative 4. Double negative, that makes my slope positive. And then I also need to note that 10 and 4 share 2 as a factor. So this is really 2 times 5, 2 times 2. The common 2's divide out of the problem. So the slope in number 3, the slope between the pair of points given in number 3 is positive 5 over 2. Let's do number 5. In number 5, my numerator, and this is m equal. Make sure you always set it to m equal because it is you're actually solving an equation. You're setting up a value equal to something. And let's say he's y sub 2, x sub 2, y sub 1, x sub 1. My denominator is then going to be 3 minus 5. I have 0 on top over negative 2. Let me do number 6, and then we'll draw a little conclusion. So in number 6, if I start with a point right here, 5 minus 8, and then my denominator is going to be negative 7 minus negative 7. So that gives me negative 3 over 0. So these are your two opposite cases in the plane. When the 0 is on top, it's okay. When the 0 is in the denominator, it is not okay. When the 0 is in the numerator over a real number, this is your 0 slope or your horizontal line. And then in number 6, this is the example of no slope, vertical line, undefined slope, because division by 0 is undefined. So those are your two opposite cases right there. Everything else should work out to a number over another number. But remember, division by 0 is undefined. Let's move on to another level of difficulty, another thought. Let's move on to the going backwards. So going backwards, you're actually given the slope and you're given one xy pairing, and then in the other xy pairing, one of the variables is missing, so you need to figure out what it is. So set the formula up, and I'll start with y minus 6, and then my denominator is going to be 5 minus negative 5. I'm going to set that equal to negative 4 over 5. So that would be your initial setup. And then you could use extremes means. So let me clean this up just a little bit. So I've got y minus 6, and that's going to be over 10. And I'm going to put the negative with the numerator. It doesn't really matter. I'll show you that it works both ways. And so now I can employ extremes means. So I have 5 times y minus 6, and that's going to be set equal to negative 40. You have the option of distributing the 5, or in this case, you could also multiply by 1 over 5. Since 40 is sitting on the other side alone without anything being added to it, this turns this into a really nice, simple little problem, and then you easily are led to the fact that y equals negative 2. So let me jot that down. Y equals negative 2, and let me give you another option for solving this problem. So now let's say I set this up, got y minus 6 over 10, and now I will put the negative sign with the 5. So So then I'm going to have negative 5 times y minus 6, setting that equal to positive 40. And now let's say that I would like to use the distributive property. And then I end up with negative 5y equaling positive 10, leading me to the same result that y is negative 2. So this is definitely an example of a problem that can be done in several other ways. And I think that is it for the basic rundown with slope, a little review of the visual graph, and a run through with the formula.